Hi everyone, welcome to episode 6 of our Python programming series. This video will be on object-oriented programming in Python. In this video, I will guide you through its core concepts like class, object, inheritance, encapsulation, polymorphism, abstraction, method overloading, and method overriding with examples. This video is going to be very interesting and important. Without wasting time, let's dive in. Object-oriented programming, as the name suggests, is a programming approach that organizes the code using objects, which are instances of the class. We use object-oriented programming because it offers a number of benefits. The main benefits include maintaining clean and organized code, allowing reusability of code to reduce redundancy, and break down complex program into smaller and manageable parts called class and objects. This makes the code easier to understand and debug the code. Python support object-oriented programming concepts such as inheritance, polymorphism, encapsulation, and abstraction. Let's move ahead to explore these in detail, starting from class and objects. The classes and objects are the very core of object-oriented programming, where a class is defined as a blueprint for creating an object, and an object is defined as an instance of a class. To understand it simply, think a class as a blueprint like a plan for building a house, where the object is the house itself built using the plan. Coming to this example, this line defines a new class named person, and the syntax is as follows: class keyword followed by class name and colon. In the next line, init method is used, which is a special method in Python known as constructor. This init method task is to initialize object attributes when they are created. When a new object is created, the init method is automatically called to set up the object. Self allows access to the attributes and methods of a class in Python, and it is a reference to the current instance of the class or object. Inside the init method, we are having the attributes of this class. In this case, these two are the attributes. In this line, we are assigning the value of the name parameter to the instance attribute name. This goes same for age also. This code defines a person class. Person1 is the instance of the class or object. As I had already said, a class is a blueprint. We are creating this person1 object from the blueprint, that is from the person class. This person1 object is an actual object which is created from this class blueprint. I hope this clear. Why we call class as a blueprint for creating object, and why an object is an instance of the class. As you can see in the example, we are creating this person1 object using this person class with the set of attributes name and age. This line prints the name and age attribute of the person1 object. It will output Alice 25. With this, we have completed classes and objects. Moving on, let's talk about encapsulation. Encapsulation is the concept of bundling the data and the methods that operate on that data into a single unit. This is the official definition for encapsulation. In simple words, you can tell encapsulation is about keeping the details of the object hidden with controlled access. It involves restricting direct access to some of the object components, which is also known as data hiding. Let's talk about access specifiers, a key component of the encapsulation in Python. These specifiers controls the visibility and accessibility of the attributes and methods within a class, ensuring proper use and data protection. Python offers three levels of access: public, private, and protected. First, public members. Public members are fully accessible from anywhere in the program. inside or outside of the class. This makes them the most open type of access specifier. Private members provide the highest level of restrictions. Members with double underscore are private. They are only accessible within the class they are defined in. Private members are useful for safeguarding sensitive data and ensuring that it cannot be modified or accessed directly from the outside class. For this, Python uses name mangling. Finally, protected members. Members with single underscore are protected, whereas double underscore are private. And don't get confused between init method and private members. Init method is not a private member. Coming to protected members, they are intended for the use within the class and its subclasses. By strategically using access specifiers, we can implement robust encapsulation, safeguarding the integrity and security of our code. Now let's move forward. Let's take a look at this encapsulation example where you created a class named bank account with a private balance attribute and a method to retrieve the balance. This double underscore before balance indicate that it is a private attribute, which means it cannot be accessed directly outside from the class. This method getBalance is a getter method that returns the value of the private attribute balance. This line creates a new instance of the bank account class and assigns it to the variable account. As I have already said, whenever you create a object, the init method is automatically called and the self dot underscore underscore balance is set to 1000 for this account object. In the last line, we call the getBalance method on the account object to retrieve the balance and print it. It will output 1000. With this, we have completed encapsulation. Let's move forward and explore inheritance. Inheritance allows new class to inherit the attributes and methods of the existing class. This promotes code reuse and reduces the effort needed to create a new class. In simple words, you can tell inheritance is like a child inheriting the qualities from their parent. Coming to this example, we are creating a class named animal. Inside the class, there is a method called speak. When called, it will print animal speak. In the next line, we are creating a class named dog that inherits from the animal class. This means that dog will have all the methods and attributes of animal class. But you can also add or override methods and attributes specific to the dog. Inside the dog class, there is a method called speak that overrides the speak method from animal class. When this method is called, it will print dog barks, not animal speaks. This line creates an instance of dog class and assigns it to the variable dog. Finally, this line calls the speak method in the dog instance, which prints the output dog barks. Next up, polymorphism. Polymorphism simply means having many forms. It allows methods to have the same name but behave differently based on the class they belong to. If you see this picture, here a man is playing three different roles based on the situation they are in, which means the same function is being used for different types. Coming to this example, both bird and ostrich have a fly method. This common method name allows polymorphism. The ostrich class is inherited from the bird class but overrides the fly method with its own implementation. This means that when both bird and ostrich have a common fly method, they behave differently. You can call the fly method on both bird and ostrich despite the same method name. Each class implementation of fly is different, demonstrating polymorphism. When this bird.fly is called, the fly method in the bird class is executed, printing birds can fly. When this ostrich.fly is called, The fly method in the ostrich class is executed, printing ostriches cannot fly. With this example, I explained how polymorphism allows a method to be called on different objects with each object representing in its own unique way. I hope this clarifies how polymorphism works. Next, abstraction. Abstraction is the process of hiding irrelevant details from the user and showing only the details that are relevant. Think of it like you are driving a car. When you are driving a car, you interact with the steering wheel, pedals, and dashboard. You need to know how to control these while driving the car, but you don't need to know the complex working of the car engine, transmission, and other internal components which are hidden from you. You can focus on driving without worrying about the detailed mechanics. In object-oriented programming, abstract classes are used to achieve abstraction. An abstract class is a class that cannot be instantiated directly. This means you cannot create an object from an abstract class. Instead, it serves as a blueprint for other classes. In Python, we use ABC module to create abstract classes, where this ABC stands for abstract base classes. Let's see how we can define an abstract class using this ABC module. First, you need to import the ABC class and abstract method decorator from the ABC module. And if you don't know about decorator, a decorator is a function that takes another function as an argument and alters its behavior. Decorators are applied using @ followed by decorator name above the function definition. Going to the example, next we define an abstract class with an abstract method. Here vehicle is the abstract class and start engine is an abstract method. This abstract method decorator is used to indicate that this method must be implemented by any subclasses. This is how we define a abstract class and method. Now let's create a subclass that inherits from the abstract class and implements the abstract method. In this example, car is a concrete class. The difference between concrete class and abstract class is we can directly instantiate to create objects. But in abstract class, we cannot directly instantiate to creation of objects. This car inherits from vehicle and provides an implementation for this start engine method. When we create an instance of the car and call the start engine, it prints engine started. To sum up, abstraction helps in managing complexity by hiding irrelevant details and exposing only the necessary parts. Abstract classes in Python using the ABC module and the abstract method decorator provide a powerful way to implement this concept. Moving on, method overriding. Method overriding is a feature in object-oriented programming referred as defining a method in a subclass with the same name as a method in its superclass. There are few key points that you should keep in mind while dealing with method overriding. These are: method overriding requires inheritance. The subclass inherits the method from the superclass and then provides its own implementation. The method in the subclass must have the same name and parameters as the one in the superclass. Finally, method overriding supports polymorphism. Coming to this example, parent is the superclass and child is the subclass. As from this definition, a method in a subclass with the same name as a method in its superclass and also having the parameters as the one in the superclass. Subclass child inherits from parent class and overrides the display method to print child class display instead of parent class display. When you call this child as display, the display method of child method is executed printing child class display as output. Now that we have covered method overriding, let's move on to method overloading. Method overloading is also a feature in object oriented programming that allows a class to have multiple methods with the same name but different parameters. Coming to the example explanation, the example class is defined with a method named add. This add method takes three parameters a, b and c, where the parameter c has a default value of 0. In the next line, we are performing the addition and returning it. An instance of the example class is created and assigned to the variable object. Calling this add method with three arguments will print 60 as output, and calling the add method with two arguments will print the output 30. This example demonstrates how method overloading works, where this example class have multiple methods of add with different parameters. Here there are three parameters and here there are two parameters. To wrap things up, let's take a look at what we have learned until now. This is it for today's video. If you found this video helpful, don't forget to like, share and subscribe for more Python programming content. See you in the next episode.